All right, so we're going to talk about 8.4 now, quadratic form. Another way of describing this topic is U substitution. Essentially, we can create an equation that is quadratic in its nature, but isn't actually a quadratic, or it might be a quadratic, but it is a little more involved in its setup. But we can kind of simplify it into an equivalent quadratic scenario that is easier to work with. So the goal is to get your quadratic, so it's AU squared plus BU plus C equals 0. And so what you're trying to do is figure out what you can have so that it is in this format. What U would make your original equation look like this. That's the goal. So we're going to have a coefficient and then our U. So if you look at the middle term, that is going to indicate what your U value will represent, or what will be represented by U. So in this case, I have an invisible A, hopefully U squared, plus BU. Does not equal, it does not plus C equals 0. So I first would want to get this to equal 0. And then the middle term, again, I have the coefficient, and this part is supposed to be the U if I can do it in this format. So I'm going to say let U equal 2A minus 3. So because I'm going to need to make sure it can be in this format, I'm going to want to make sure that this part is AU squared. So I want to know what U squared is. So if I square this, it looks like that. All right, so let's see, do we have that? So we have A would be invisible 1, U squared, so there's the U squared, minus B U plus C equals 0. So I'm going to rewrite this as U squared, 1U squared, minus 9U plus 20 equals 0. So that's a simplified version of this quadratic using U substitution to make it simplified. So now I can solve for U. What multiplies to 20 and adds to -9 is -4 and -5. I'm going to have U minus 4 times U minus 5 equals 0. Because the leading coefficient was 1, I didn't need to do the grouping. I could just use these values to factor it. So what makes this 0? The zero product property is 4. 4 minus 4 is 0 times -1 would be 0. Or if U is 5, we'd have 1 minus 0 equals 0. And so both of those would make this statement true. But I'm not trying to solve for U, I'm trying to solve for A. So I'm going to do back substitution. I'm going to say, well, U represented 2A minus 3. So this is 2A minus 3, so that has to equal 4. I'm going to add 3 to both sides and then divide by 2. So 7 halves. And then here, same thing. This is 2A minus 3. It's equaling 5. Add 3, that gets me 8. Divide by 2, I get 4. You could also have done this because it is a quadratic, the highest exponent will be 2. If I FOILed this all out and got it equal to 0, I could factor out the GCF of 2 and do this by factoring using the A times C, because the A is not 1, the B on the bottom, and then do grouping, and you'll end up with the exact same factorization. It'll be giving you the same answers. Or you can use quadratic formula. So the next example, if I look at the middle term, it's equal to 0. The middle term, this would be the B, and this would be the U, coefficient, and then the U. So we're going to say let U equal x squared. What that means is that U squared would be x squared squared, so x to the 4th. So this is indeed U squared, 1U squared, minus 6u minus 27 equals 0. If this had been like 5 x to the fourth, then it would be 5u squared. If this had been x to the third, then this would not be able to be written as a quadratic with u. So what works for multiplying to negative 27 and adding to negative 6 is negative 9 and positive 3. So your answers are u would be 9 or u would be negative 3. Well, again, we're not trying to solve for u, so we have to back substitute and say x squared equals 9. So that's what u is. Remember, u is x squared. And here, x squared equals negative 3. So we're still trying to solve for x. So to get rid of the square, we square root. And when you take a square root, don't forget plus or minus. The square root of 9 does simplify to 3. Taking the square root here, we're going to have plus or minus I from the negative, square root of the negative, it gives us the I, and then the square root of 3 can't simplify, so root 3. So you may, if you've watched my other videos, you may recall that the highest exponent tells you how many solutions there are for a polynomial, and so we would have 4 solutions. Positive 3, negative 3, positive I root 3, and negative I root 3 are your 4 solutions. That is it. There is an alternative to that, and that is that if you instead see this like we did earlier in the course when we had a fourth power and a squared power, when we talked about factoring the special ones where it had 4 and a 2 there, we did factor it, just would have an x squared, so that your middle term, your O and your I, give you the x squared, and the f part would give you to the fourth power. And so solving it by factoring, you get the exact same solutions as we did when we did the u substitution. So I'll project a few more just to illustrate how we determine u. Again, is that middle term, so it's bu, so the u is the square root of t in this case. And then we just make sure that this can be written as something u squared, something u plus or minus something equals 0. Most of the time, what you guys are going to encounter for my assignments are factorable kinds. It is possible to solve these when it's not factorable. They're just way more involved. It's involved enough to have a u, and then you have to make sure it's 0, and then you have to think about extraneous solutions. And the last thing I want you to do is also have to work with quadratic formula and all of that. So most of them will be factorable for the solving. So this factor is like that. U could be 5, u could be negative 3 when you solve it. But again, we're not trying to solve for u, we're trying to solve for t. So we back substitute that u is the square root of t. When you square, you need to check for extraneous solutions. That was from a prior lesson on the square root method, 8.1, I believe. So when I check, I realize that it doesn't work for 9. That's an extraneous solution because, well, negative 12 does not equal 0 when you plug it in the original problem. The shortcut is also to recognize a square root cannot be a negative. So even before this, I would have known, even without checking, I would have known this doesn't work. I could have stopped right here and then just had this to check. All right, let's see. So then this one down here, you could kind of squeak in the fact that there's 0x squared, and it will work for u substitution. You could also solve this as a difference of squares. There's a couple options. The point I wanted to make on this is that if you do the difference of squares, these are your 2 solutions. To get rid of the square, you square root. You might need to rationalize your denominators if you end up with a square root in denominator, you can multiply by the conjugate or just multiply it by itself if it's a monomial. All right. So there's a few examples in your textbook that I think are worth discussing, and that is example 6. I wanted to mention that they accidentally have the word cube root. They meant square. They should have put square root. This one shows how the quadratic formula is needed because it isn't factorable. So here's an example of the quadratic formula being involved in these U substitution problems. And then the example here I put down because of the extraneous solution. And then this one I put down because of, I think it was the square root property and having a negative, so you have I involved is why I did that one. So those were just a couple other examples from your textbook. It'd be a good idea to review. All right, that is essentially what I have for 8.4. Again, the U comes from the middle term, and you should be able to write it in this format. And then don't forget to factor or use quadratic formula if it's not factorable. Back substitute, so you're actually finding the value of the variable that you are going after. All right, have a good night.